So, welcome to API security. Whose API has been hacked so far? Everybody. So hopefully after that talk, nobody gets hacked anymore. So just a short notice of myself. So I'm Andreas Falk. I'm coming from Germany. A mid-sized company located in the south of Germany at Stuttgart. If you want to visit Mercedes, Porsche and something like that, then visit Stuttgart and come to our company. We're doing basically consulting, and security is one of my main focus. That's why I'm here today as well. I'm also a member of the Open Web Application Security Project. And also the OpenID Foundation, because I also do a lot of stuff into identity access management. But that's all what I wanted to tell you. So this is the Hitchhiker's Guide for the current talk, so hopefully we can manage it in time. That's always a bit difficult. So we will start with a short API 101, just to be on the same side here. Then we will have some parts how hackers really discover your APIs and how they analyze your API. So that's the first step always. If a hacker wants to hack your API, the hacker first tries to find your API, and then secondly try to find documentation that might be online, which is quite helpful. And then on the next step, then the hacker will try to attack your API. So no hacker usually, when he's hacking professional, just starts hacking suddenly, always needs some preparation. I also have some online GitHub repository with some demos where I will show some small part of that. I will also extend that GitHub repository, so that's just a starting point, so I will also extend it with some more gRPC, GraphQL stuff as well. So now that's just a starting set. So APIs 101, just a quick overview. So most of you likely use REST. So who is using REST APIs? Oh, most part. Who is using GraphQL? And who is using gRPC? Oh, less people. So a clear winner, REST APIs. So I can quickly jump over that. You know all that with the resources, the representation of resources, hypermedia controls and stuff like that. You can have documentation like Open APIs, Swagger UI, also RESTful API modeling language, or the Spring specific one, the Spring REST docs. This is GraphQL. GraphQL has the big advantage to REST APIs that you, as a client, are in control what data you want to retrieve. So in a REST API, you are really dependent on what the server defines. You get the full-blown data or you get no data. So these are the choices. In GraphQL, you can fine-tune which attributes you want to really retrieve from the API. That just fulfills your need as a client. So that was also specified. So my screen has gone now. So the third one is gRPC. So that's invented by Google initially. And this is a bit different to REST APIs in GraphQL because it has a binary protocol basically. So with protobuf, it has a classical client-server architecture. Where we have some remote procedure calls in place. So it compares more maybe some of you still know the CORBA, RMI stuff, so this is comparable more or less to that one. We see here the definition. We have a server, we have a stub on the client, and we have a definition how the service looks like. So the first step is how to discover your APIs and analyze APIs. So the first thing you have to notice is what kind of API you are really building. Do you build a really completely public API, like providing weather data that everybody else could just grab via the API? Are you providing some partnering API? So in Germany, we also have services that checks addresses for validity, or if there are valid addresses, for example, we have APIs for that. So they are semi-public somehow, so not everybody can access these APIs freely, because you have to pay for this kind of APIs. You need some API key or stuff for authentication. And the third one are the completely private APIs. This is, I would say, 90% of all APIs we build. So these are usually the APIs you build in your companies that are provided just for your own clients to be consumed there. Yeah, and these three types of APIs require different kind of authentication level as well. So the public APIs are there to be found, actually. So they are easily to be discovered. Documentation is online. But these are also provided to not provide really sensitive data from your own company. For your internal APIs, your private APIs, you need a different level of authentication and of discoverability. So usually it's not really good if customers or if hackers can just discover your APIs on the internet, complete with all documentation, so they can directly build Postman collections from your API. So that's a clear winner for the hacker, if the hacker can just have a Postman collection and then hack on basis of the complete Postman collection. To actually find your APIs, you have different kind of tools there. So you have search engines like Google. You have the search engine of the hackers called Shodan.io. So who knows Shodan.io? Awesome. So it's a really helpful search engine. I can recommend that to look for that. You find in Shodan.io you can find everything that is connected to the internet somehow. So all IoT devices, power plants, webcams, baby phones that are connected. So you can also very easily search for your own baby phone, maybe your own connected devices, if they can be found in that directory. So this is also the #1 search engine for hackers, usually. And you have some specialized tools like the OWASP MS tool. Also, we have a specialized search directory called the Programmable Web website. Here I can also show some small demo for that. So I already prepared some Google Docs. So this is a classical Google search to find APIs. So it tries to find some API in the URL that also has index set. So this way you easily find publicly available APIs via Google very easily. The second thing is then the Shodan.io. So here I just search for application JSON type. And with that, you can also quite easily find different APIs that are running on the internet. You also usually find very other interesting parts in Shodan.io. So for example, it automatically checks if you have weaknesses in these SSL certificates, if you have a SSH shell that could probably be accessed on that server, if you have vulnerabilities on that server. So that's everything Shodan.io detects automatically for the hacker. So if a hacker sees your API, and it reports some vulnerabilities, the hacker will then in the second step try to misuse your API just by using some of these reported vulnerabilities. So that's a quite easy task then for the hacker here. We also have what is called the OWASP AMAS tool. I also, for time reasons, executed that beforehand. So in that case, I just wanted to ask, what kind of APIs does Twitter.com provide to me? You can also search for your own company host with that tool. This is just a passive scan, so that's completely dangerous, so the police won't call you for that. It also has an active scan ability. This is then the dangerous part, so please only use the passive scan on websites that you don't own. So if you own that website, then you can maybe also do an active scan. As you can see, I just scanned Twitter here, so it found plenty of APIs here, all running on Twitter, so it's really astonishing what kind of APIs are really running on that website. Yeah, very long list here. So the next thing is, for example, GraphQL provides a documentation via Spring Boot as well. So if you just use the Spring Boot GraphQL thing, then it also provides you with the schema online, which is quite good for hackers to grab your APIs as an example. You also have open API stuff. Let me check that one. I don't have it. So these are API docs that are provided via your Spring Boot application for your REST APIs, for example. This can be directly imported into Postman collections. We also have the nice representation, like here, the Swagger UI, that's also provided. And also the GraphQL thing, where you can directly then query for stuff as a hacker. So if the hacker finds that environment on your production side, then the hacker can easily play around with your GraphQL queries, which is kind of bad. So please don't make this kind of tooling available on your production side if you have a private API. So that was the first thing to really discover such kind of APIs. Here I noted down the important properties that you should look at if you provide APIs, like, for example, the Spring Doc thing. So Spring Doc is a great framework that automatically can generate all that open API stuff for a Spring Boot application. You can switch that off for production, or you can put authentication, authorization in place so that only authenticated people can access that documentation. The same for GraphQL. You can also disable the GraphQL environment very easily, and also the schema printing can be also disabled for production systems. So now the next step is hacking APIs. This is where the interesting part for the hacker really starts. So APIs, from a security perspective, APIs have different attacking points. So the first one is the HTTP method. So if it's a get, a post, put, delete method. So hackers usually, if they detect some method having a get request, then they try to change the exact request to a post or delete request and try to sneak with that payloads that you get from a get request and just rechange them, putting them in a body for the next post request and play around with your API a bit. So you have to be careful that you don't provide too many HTTP methods that you don't really use in your API by accident. So luckily, usually in Spring, you just provide the get mapping, the post mapping, the declarative way you really need. The next is the protocol, the host name. The hacker always checks if there is a HTTPS connection. If there is no secured connection, that makes it really easy for the attacker again. She also looks for URL stuff. If there are fancy stuff in URLs, sometimes you find JSON Web Tokens as query parameters, or even some other sensitive data, like some typical IDs that could be interesting for the hacker. The same is for the path in REST APIs, for example. The path is really interesting for the ID, for example. And then you trick around with the ID, you do some enumeration to maybe find data from other users you are not authorized to see usually, but you have some weaknesses here as well. And also headers are really interesting. In our headers, usually you transmit your JSON Web Token for the authentication part, and that's also a good point to steal actually JSON Web Tokens. If you are playing man in the middle somehow, then you can just grab these JSON Web Tokens. That's why you always need to have a secured communication, so that a hacker cannot grab that very easily. And the last thing is also the payload. Don't forget the payload. In REST, in GraphQL, and all that stuff, all in protobuf for gRPC. This is the most important part. And lots of developers forget about that authorization and also validation on data and what you really expose via your payload to the client is really important. So lots of people expose really too much data for such APIs because we might think, oh, in the future we might need also that and that data from our server. So let's put all the data already inside the API and let the client filter out data that is not needed. But if a hacker attacks your API, the hacker sees the full-blown result of your API, so the hacker does not filter out anything and just reuses that sensitive data that is inside here. This is the most important point if you want to start with API security. This is the OWASP API security top 10. So who knows the OWASP top 10 already? So we have the standard OWASP top 10 for web applications, and this is the one, a special one for the API security part. They just recently published a new version for this year, release candidate 1, so my presentation is already based on the latest OWASP top 10 here. And we will now have a look at different types of attacks that can happen here. So really the number one attack for APIs is authorization for object level. So the typical thing, you try to access a vehicle, for example, with an ID, 123, that usually belongs to a specific user, but the other guy can also access the same vehicle, but the vehicle does not belong to that user. So you just try to enumerate different vehicle IDs, and then you get another vehicle that does not belong to your own data. So that's the typical number one top 10 security issue we have for APIs. So authorization is really the most important part here for our objects. Before I jump in here, let's just show some example here. So I also provided some Postman collection here that I will also upload later on the GitHub project. And I have several applications running here, like a gateway, maybe we'll see that later. And I have an insecure API application. I have a secure API version of that. So we can also have a look on the insecure part and also on the secure part. So what you see here is also a bad pattern I often see, also often have seen in the past in my customer projects, that customer projects don't build upon standards like OAuth2, OpenID Connect, but they try to build their own security service, crafting their own JSON Web Tokens, for example, which usually is a really bad idea because this is a really hard thing to do it really in a secure way, and you very easily can make holes into your security architecture that way. So I have a login here. I have also a login service where I use some symmetric key for signing my JSON Web Tokens. And that's my service to actually log in here. So here, as you can see, I built my own JSON Web Token with some payload of myself. In the second API top, we will also see how to crack a JSON Web Token in a demo. But what I wanted to show with the login first, because I have to log in first to really be able to play around with that stuff. And now I have some API here. I have a vehicle API, so maybe just try out the number 1. So I get a vehicle back, BMW in that case. And what I now can do is just enumerate through different vehicles. So that's another vehicle that clearly does not belong to me because you see a different owner UUID for that vehicle. That's the classical OWASP top number 1 problem, that you can really access any vehicle that does not belong to you. We can have the same also for GraphQL. With that you have a query with an identifier here as well. So let's try that one. As you can see, we also get back the same vehicle data, and we can also play around again here, change the identifier to 2. And we get back a different vehicle. So that's the OWASP top number 1 here. So make sure that you always authorize these things. And this is how to prevent that stuff. Always put authorization controls on the object level. In Spring, you use Spring Security usually. You can have that pre-authorized, that post-authorized annotations, for example, to filter out things or to check before the request goes through. Or you even have the ACL support to have a fine-grained object level support to check each and every object if a user is allowed to access that thing. And also a second important thing is don't make it too easy to enumerate IDs. So it's much better to use UUIDs, for example, for these kind of IDs. It's much, it's much more difficult to really guess a valid ID of another vehicle if you use that kind of ID enumeration here. And also important, always write automated tests for Spring Security in that case to really make sure that you have validated your complete authorization permission model. And really important is not only to do a positive testing, but you also always have to do a negative test if a user that does not belong to that vehicle cannot access that vehicle. So often developers forget the negative path and just test the positive one. So number 2 is broken authentication. That's all around the authentication part. And typically the authentication is not broken itself, so not the authentication algorithm mechanism is broken. So like using OAuth, OpenID Connect according to the standards is usually quite safe. What is often the cause of broken authentication? That people don't stick to the standards, they try to build their own security service, they craft easy-to-guess JSON Web Tokens, or use insufficient authentication, like still using basic authentication should not be a standard nowadays, or they craft their own API tokens and stuff like that. So I also already have seen customers building partner APIs and then handing out a JSON Web Token, a static one that is valid for 2 years, and they can reuse that JSON Web Token on that API for 2 years. So if that gets stolen, the hacker has 2 years time to really hack your API. So this is the typical thing here. So now we try to play around with our authentication. Now first I just show the usual thing that you use for authentication. So this is a JSON Web Token. I just marked the really critical points in a JSON Web Token. So it starts with the header. The hacker usually tries to play around with that signature algorithm in the header. So with the signature, that algorithm part, you signal to a server that gets the JSON web token what kind of signature algorithm was used to build the signature. So the server then knows how to validate that signature. So it can be a asymmetric or a symmetric algorithm. In that case, it's an asymmetric one, RSA-256. So the server needs some public key to validate the signature. And some hackers then try to manipulate that JSON web token, try to put the value none instead of the RSA-256 and try to trick the server to not validate the token anymore. Because if it's an easy implementation, you just look at the algorithm, it's not a signed token, so we let that through directly. It's not needed to validate that. So quite easy trick that you can do. Also, they trick around with the subject, which is the unique identifier of such a JSON web token. And also, really dangerous is blindly following all the URLs that are part of the token. So don't just blindly follow all redirects or the URLs that are part of such a token. Also, attackers try to manipulate tokens and put in some malicious URLs. And if you just blindly follow them, then you could also have a problem. And also, always check the expiry time and date of a token. That's the second really important part to always validate. First, the signature. Secondly, the expiry date. And optionally, you can also check for the audience that are also marked here. So for whom is the token really intended? So it's also a recommended thing that you don't issue tokens that are valid for your whole backend worlds. So also restrict these kind of tokens for different domains, for example. One for the customer domain, one for the shopping domain, so that you cannot access all backends with just one token. Now let's see if we can play around with that token that we got. So I just try to log in again, because the token has also some expiry set. No. Just copy that one. So I set that as an environment variable to make it a bit easier. And now I think I have that from before. That's the one. So there is a nice tool available on the internet called the JWT tool, with which you can really test your JSON web tokens also against your API if you have vulnerabilities for tokens in that case. So it now tests against my insecure partner API, which also is self-crafted, so it does not check everything as it should. And I just do some playbook attack on that API, trying my set JSON web token, and I just check on a response that I expect if the token is accepted of that API, and let's see if we have success. So all the green lines indicate that it has successfully manipulated the JSON web token and got access to our API. So it used different techniques like the none algorithm and all that stuff. So if you get such a result on your API, then please recheck your API if it's really validating JSON web tokens correctly. The second thing is that you can do is also, let me copy also that one. You can also do a brute force on your JSON web tokens. So with that, you can publicly download such security lists that have well-known passwords that usually are used as a secret for your symmetric signature building of a JSON web token. And we just try to find out the password of the JSON web token. So let's see, it found out. So this is the correct key. So don't use that key as a secret for your own JSON web tokens. So the same as 1, 2, 3, 4, 5, 6 as a not really good password. Also check for such secrets. these are a bit longer secrets because you need some minimum length to build that symmetric key actually. So it's not a really short one, but these kind of passwords is available on several lists on the internet, and it quite easily you can download and just crack the JSON Web Token. If you have that password, you then can sign your own JSON Web Tokens, and your API is really crushed. So this was just the second one. Let's go a bit faster through that thing here. We have the broken authentication. So don't reinvent the wheel. Follow standards of OAuth 2, OpenID Connect to get tokens. Use multi-factor authentication for all that stuff. And also learn how authentication really works. So education is key as well here. So really understand how it really does these things. Also best practices, I already mentioned that. So number 3 is then the object property level authorization. This is the thing that attacks your payloads. As you can see here, we have a payload that clearly does have data that might be sensitive, that is not belonging really to that community post here. So what is intended here is that users can also exchange community stuff with each other and share some insights. Oh, I got a new vehicle bought and I have some problem maybe with my vehicle. Who can help? But what else is included here is like the email of the user, and this is a whole list. I just copied the first entry. You get a whole list of all other users with all email addresses and also with the vehicle IDs of other users. And then you might misuse that vehicle ID, copy it from there, and use it on other API stuff. So always be careful what to share in your APIs here. So prevention is quite easy. Build special value objects that you are returning from your API. Don't return directly your JPA entity beans from the APIs. Also, JSON ignore, JSON filter annotations are quite useful to restrict the data from returning to the clients. And always, you aren't going to need it is also a clear rule to follow here. So if you're in Europe, you also are maybe restricted by the general data protection regulation as well here. So API 4 is unrestricted resource consumption. This is the typical denial of service attack that can happen. So if you allow everybody to just flood your APIs with lots of requests, this might be bad. Sometimes you also have some pricing model maybe on your APIs, so you might limit the amount of requests that can be made to your APIs. And the classical thing to do here is put an API gateway, like the Spring Cloud Gateway is a good solution here in the middle. And then there is a rate limiter as part of the Spring Cloud Gateway. So whoever will be in my workshop later, I will then show also a practical thing of the API gateway there. So implement rate limiting is good. Also specific to GraphQL, there is some batching features available. Also restrict the number of batch elements for GraphQL. That's also a good thing. And also the query diff should be restricted. So in GraphQL you can really recursively make request calls with lots of data, and that can also be a problem. And also take note of your containerized applications. So always limit the resources, the memory, CPU on your Docker containers as well, and also in your YAML files of Kubernetes workloads. That's also really important, to not overconsume your services. So this is what query batching looks like. So here somebody tries to also activate credit cards with a batching approach of GraphQL, so be careful with such features. So number 5 is the broken function level authorization. This is the clear role-based authorization. So one API is only for administrators, the other API is for standard users. Like here, we have the users API, and the delete function should be an admin function, but in that case, also a standard user can also delete those things. So to prevent that is also a classic Spring security thing. Always put the different checks on the web layer, for example, the request matcher that checks then your admin API if it has the correct role available, the user, and also on the method level you can also do the pre-authorized checks and also write tests for that. Number 6 is a classical one, the server-side request forgery. Maybe just let me show that quickly. Where do I have it? The poster command here. So for that I have some valid requests where I put in some partner API. So this is just to contact my workshop for car repairing stuff, for example. And every workshop just provides their own API to my service, and I just call their API for some reason. And this could be a problem for that server-side request forgery part. So let me just check that one. I'm not authenticated, just log in again. Now try to send it. So yeah, what I get back is also another problem. So always check what is returned by other partner service. So they might also send you some cross-site scripting attack payloads. So be careful of that as well. So that was the intended way, but you can also easily just put in our Spring I/O website here as well. So let's see what happens in that case. So it takes a bit longer, and if you visualize that, preview, then you get back, without pictures, but you get back the Spring I/O website. So this is a classical server-side request forgery attack. And to be safe from that, use, for example, whitelisting of remote hosts, and also validate and sanitize the results coming back from that API. Security misconfiguration is a classical thing, also from the OWASP, the classical OWASP top 10 list. Here you have usual things like the cross-origin resource sharing problem, that you put wildcards on the cross-origin resource sharing and open up your API for all kinds of clients, also the malicious clients that you don't want to have. Don't use wildcards, for example, here. Then all communication should be secured via HTTPS, so always use TLS protocol everywhere. Not just from the client to the gateway, but also from the gateway to your backend services as well. Use things like Istio on Kubernetes that makes it quite easy to secure all the communication. Also switch off stack traces, so don't report errors to the clients with stack traces. That's also a really painful thing that makes it really easy for the hackers. And always review, update your configuration, your YAML files and stuff like that, cloud services. So that on the bottom is also a classical failure that you can do for gRPC, for example, to use the insecure channel credentials and then forget to switch that on production to the secure one. So that's also a quite helpful thing for GraphQL. I also have the URLs in my slides for that. So here it checks on what features are enabled and what features could be potentially dangerous here as well. So lack of protection for automated threats is a kind of special thing where it is quite difficult to defend against, because that really depends on what your business is for the APIs. So the thing is here that the attacker may craft some automated scripts to misuse your API for business reasons. So for example, if you provide an API with some preview tickets to be sold for a really famous star coming to your country, and you want to restrict that somehow, then some hacker just automatically does some scripting and buys all these tickets in front of other visitors. So this is the classical thing here. So here also limit the amount of requests possible, block automated scripting from happening, block bots and stuff like that. So also have a good monitoring so that you can detect strange things happen on your APIs. So the last one, one before the last one, is the improper inventory management. It's really important that you have an inventory of all your APIs that your company provides. Otherwise, it is quite easy that you forget about legacy APIs, about versions you should have taken down already. So this is also very important. And it should also be including data classification. So which data is processed by which API? Do I have really sensitive data in some API? There I might need some other authorization, authentication level that for easier APIs. Also check for that one. And provide documentation for each and every API, but don't provide it to the whole internet. And provide that inventory of all the APIs. So also have a version management as well. So you always know which different versions are available on your API. And the last one is the unsafe consumption of APIs. We've already seen an example of that with our workshop API. This workshop API just returns some cross-site scripting payload to us, so we always have to check partner APIs and don't really only trust to these partners. So you never know what your partner is returning to you as a payload, so always do input validation as well for the partner APIs as well, not only for the client side. And also connect via TLS to that thing. Also don't blindly follow redirects. In most HTTP client stuff, you can switch off automatic redirects, for example. So this is also a quite easy one. So this is the summary of that thing. So you have 4 blocks that you can defend your APIs. So first is the security governance, build an inventory of all your APIs, what data is processed in the API, classify this data, then have some API runtime security. There are also great open source, great commercial tools that can monitor your stuff. So if you have some abnormal API traffic happening, then you recognize that very early. Then secure API development, use lists like the OWASP API security top 10 to make it better. Do code reviews. This is a really important thing. So always have a security code review done by some different developer for your APIs. This is also strongly recommended. And the last thing, also perform API security testing. There are also tools for dynamic application security testing. One I have also here behind the scenes for the JSON Web Token hack thing. So this is the burp suite, for example. And for my hack I just did before, it also detected the weak symmetric algorithm for the JSON Web Token. And also, I think it also could get the password, so it also grabbed the password directly here. So use tools like the burp suite, the OWASP SEP tool to dynamically find the flaws in your application. And these are 3 recommended books. API Security in Action is more developer-focused, how to build these things in a secure way. And Hacking APIs is more or less for REST APIs. And there's also a quite new book, Black Hat GraphQL, which also tells you everything how to hack GraphQL APIs and how to defend against that. So that's all what I had, and time is up, I think. So just got through that.